Hey there. In SpriteKit, there are two main ways objects can interact: contact and collision. A contact is when you just get notified that two objects touched each other. A collision, on the other hand, is when SpriteKit automatically calculates what happens when one object hits another. In this video, I'll show you how to implement both of these in a simple SpriteKit project. Let's start fresh with an empty SpriteKit scene. First, we'll set a background color. I like using hex codes for colors, so I'm going to use this little UI color extension. Feel free to copy it if it's helpful. If you run the app now, you should see the background color applied. Now, let's add a ball. We'll write a method to define how the ball looks, where it should appear, and then call that method from didMove. Just a heads up, for this demo I'm hardcoding the position, so it will only look right in portrait mode. When you run it, you should see a red ball near the top of the screen. Now let's add a box. This will be the object the ball bounces off. Again, we define its look and position, then add it to the scene. I'm gonna use SK Sprite Node this time, but SK Shape Node would work too for a simple rectangle. Now if you run the app, you should see a blue rectangle near the bottom. Let's add one more object, a ghost zone. The ball will fly through. Same process as before, define it and add it to the scene. At this point, when you run the app, you should see the ghost zone sitting in the middle of the screen. Now that we've got all the pieces in place, let's define the physics. A nice clean way to handle physics categories in SpriteKit is to create a structure that conforms to option set and hashable. We will define physics categories for the ball, box, and go zone. Each one needs a unique bit set to 1. This is important for things like collision and contact detection to work properly. There are different ways to do this, but I find this one concise and readable. Next, we define which objects should collide and which should trigger contact notifications. It's best to define these interactions in both directions, even for static objects like walls. Technically, the wall isn't hitting the ball, but defining it both ways avoids bugs and makes things more consistent. Every SK physics body has 3 important masks: the category bit mask, which is just the raw value, the collision bit mask, and the contact test bit mask. We calculate the last two using a simple OR operation. I've called the parameter collisions, even though it's used for both collisions and contacts. Feel free to rename it if it seems confusing. The nice thing about this approach is that everything is in one place. It's easy to see and update what interacts with what. You could even write unit tests to make sure you are not missing any bidirectional rules. Or you could generate them dynamically. I just find the manual way a bit more readable. Now, let's update the objects to use the physics settings. Starting with the ball, we give it a circular physics body that matches its size and set all the masks using the physics body structure we just made. We'll also tweak a few physics properties so it bounces nicely. If you run the app now, the ball will fall, but it will pass straight through the box since we haven't added physics to the box yet. So let's fix that. In the method where we add the box, we'll give it a rectangular physics body. Set is dynamic to false so it doesn't move, and set the masks. Now, if you run it again, the ball should bounce off the box like expected. Next, let's set up physics for the ghost zone. Right now, the ball passes through it, but we don't get notified. By assigning it a physics body and the right masks, same as the box, we'll be able to detect contact without affecting the ball's motion. When you run it now, everything will look the same, but now we can detect when the ball goes through the ghost zone. Let's move on to contact detection. First, we set our scene as the physics world contact delegate. Then we implement didBegin, which gets called whenever two bodies touch. Inside, we grab the category masks of the two bodies and OR them together. Then we unwrap the nodes and use a switch to check for different contact scenarios, like ball hitting box or ball passing through ghost zone. For this demo, we'll trigger some simple visual effects. When the ball hits the box flashes a different color. And when the ball passes through the go zone, we'll show a glow effect. Let's define both of those now. For the flash, we'll use an SK action sequence that changes the color, waits a bit, and changes it back. For the glow, we'll create a temporary rectangle that scales up, fades out, and disappears, just enough to give a nice visual cue. So, when you run the app one last time, the ball drops, bounces off the box, which briefly flashes, and passes through the go zone, which glows. That's it for today. There are many ways to handle physics in SpriteKit, but this setup has worked really well for me so far. Let me know in the comments if you prefer a different approach. And if you'd like to see more SpriteKit videos like this, don't forget to like and subscribe. Thanks for watching.